look at the ArcHydro layer, which is part of the living atlas of the world, you've got river systems all over the world, and at this scale, you're seeing major rivers, right? The Nile, the Ganges, the Yangtze, the Mississippi, the Missouri, the Amazon, etc. Okay, so let's go ahead and adjust what we're seeing right now. Okay, at this scale, we see major rivers and their tributaries. But as we zoom in on anywhere in the world, I'm going to pick the USA here to zoom in on, but now I see tributaries, additional tributaries that I didn't see before. And as I zoom in, I see even more of those tributaries. I also see in the USA these dashed or actually dotted brown lines. What are those? That is the watershed boundary. So for example, if we go up to Iowa, we see a major watershed boundary going through the middle of the state, and as dividing the Missouri River drainage on the west side of the state, about the western third, and the Mississippi drainage, which is on the eastern 2/3 of the state. If we zoom in some more, we're going to see sub-watershed boundaries. And the nice thing about teaching about scale here is if we zoom into a watershed boundary here in the middle of Iowa, it may not be that prominent on the landscape, certainly less prominent than something like the Continental Divide in Colorado, or the divide over on the Appalachian side, or the divide in the Alps or in the Himalayas. But we see that there is a watershed boundary here. Look, this river, Moser Creek, is draining off to the south and to the southwest, whereas this one right here is draining off to the southeast. And then this one here is draining off to the north. So you've got a watershed boundary. What does it look like on the ground right there? Wouldn't that be fascinating to determine? Well, look, you've got tools that allow you to answer these what-if questions. And that's what's great about these tools, is that you've got, oh, now I've got the satellite imagery. And again, it may not be that prominent on the landscape if you go to that location and look at it, but look, it's a watershed boundary nonetheless. Fascinating to be able to do this inside these tools. And that is the third way then. The last thing I wanted to show you about that particular one is, you probably saw me turning off this layer at the beginning, but here I've got a trace downstream. This is a tool, an analysis tool that you can run inside ArcGIS Online. It's one of the analytical tools. You've got 20 or 30 analytical tools at your fingertips. But here I've done a trace downstream. It's the classic lesson where we drop a bucket of water on the landscape and we see where it goes. What ocean does it eventually flow to? So here I started it at basically Boulder, Colorado, and we can see that it actually flows all the way down the South Platte. It joins the Platte, it goes into the Missouri, goes into the Mississippi River, and then on down to New Orleans. Okay, fascinating. And if we look at the table of data there, of the trace downstream, let's take a look at that data table just real briefly. We can get some information about that. It's 3,800 kilometers. And this is the data that the water course, the trace, was derived from the 30-meter DEM. So it's wonderful to be able to do that. Where does the rivers flow? Getting students of all ages to understand the relationship between topography and river systems, and at multiple scales. Getting them to think about river systems, trellis drainage, dendritic drainage, oxbow lakes, and other facets of the river system, and their relationship to geomorphology, climate, weather, precipitation, etc. Fascinating to be able to do this. Okay, so we've got a couple of things that we've done there in number 3, the third way to teach about scale. Let's go